postulate is just a statement accepted as fact. So we're going to learn about theorems later, and theorems is a statement that's been proven true using a proof. A postulate is just a statement accepted as fact. So all these postulates you have to kind of know, which we've kind of already talked about some of these, like through any 2 points, there's exactly one line. So this postulate right here just says if you have 2 points, you can draw a line. And we've kind of talked about that in the first chapter. So through any 2 points, there's exactly one line. The second postulate says through any 3 non-collinear points, there's a plane. 3 non-collinear points make a plane. Okay, when we're determining which postulate to use on each problem, for this first one, we're only talking about 2 points. So for this one, it says a line contains at least 2 points. So if you see a statement that's talking about 3 or more points, we're going to use this one. So a line contains at least 2 points, but it can contain infinitely many points. A plane contains at least 3 non-collinear points, so it can contain infinitely many points. And then if you have 2 points in a plane, then the entire line containing those points lie in that plane. 2 lines intersect in a point. We talked about that. And the intersection of 2 planes is a line. So this is what your assignment's going to look like. You're going to have some problems that are always, sometimes, or never true. So like the first one, we have to decide whether that's always, sometimes, or never. So it says points A and B are collinear. Would they make a line?
Yeah.
Always, sometimes, or never?
Always.
Always, yes. Always. 2 points always make a line. Line R contains only 1 point P.
No, never.
Never. Because one of the postulates says, let's see if I can get back to it. One of the postulates says a line contains at least 2 points. It can never contain 1 point. You have to have at least 2. Okay. 4 points are non-collinear. So 4 points are non-collinear. Sometimes, because they could be collinear. They could be on the same line, right? They don't have to be, so that would be a sometimes. So you're going to have some problems that are always, sometimes, or never. If 2 coplanar lines intersect, oh, this one's kind of weird. If 2 lines intersect, then their point of intersection lies in the same plane as those 2 lines that intersect. So if I have 2 lines in the same plane that intersect, that point where they intersect would also always be in that same plane. Do you guys get that? That's
I don't understand how it wouldn't be in the same.
It has to be. So it's always, yeah. I don't understand how it wouldn't be either. Because if they intersect, but it says 2 coplanar lines, so they have to be in the same plane.
Well, it could be diagonal though. One can be diagonal while the plane is straight.
It's always, don't argue.
I guess I don't understand. What do you mean, like this?
Like,
But if 2 lines are in the same plane, if they are coplanar, then that point that they cross would have to be in that same plane, right?
Yeah.
That's what I would say. I would say always.
I'm going, yes.
I don't see how it couldn't be. Okay, so these you have to identify the postulate that belongs to each statement. So this is where it gets tricky. So it says line M contains points F and G, but also point E could be on that line. So this is the one that I want you to use, which you'll have multiple choice. You get to choose. I want you to choose the one because, so you're looking at lines and points. So the only ones with lines and points is 2, 1, and 2, 3. Does that make sense?
Mm-hmm.
So 2, 1 is just talking about 2 points only. But do you guys see how 2, 3 is talking about 3 points or more?
Mm-hmm.
So that's the postulate I would want you to use, 2-3 or 2.3.
So would we write 2.3 or?
It's going to be multiple choice drop down. So that would be 2.3. A line contains at least 2 points. And it's going to be a drop down choose. Is it unlocked?
No.
No? Okay. points A and B are collinear. So this just has 2 points only. Do you guys see that? Only points A and B. So which one do you think that I would want you to use? Which one? The first one. What'd you say? 2.1. The first one. So if it's only 2 points, use the first one. If it's 3 or more points, use the third one. Okay, points A, B, and C are non-collinear. A, B, and C are non-collinear. Points A, B, and C determine a plane. So now we're talking about a plane. Which ones of these is talking about planes?
2.2.
2.2, 2.4, and 2.5. Well, 2.5 is talking about a line and a plane, so that one's out. So it's going to be 2.2 or 2.4. Since it's only talking about 3 points only, you're going to use 2.2. If it was talking about more than 3 non-collinear points, I want you to use 2.4. Okay, is it tricky so far?
Yes.
It's kind of tricky.
Oh.
Okay, oh wait, that was so this one would be 2.2. Planes P and Q intersect in line M. So that one's going to be planes P and Q intersect in line M. So do you see how 2.7 is talking about if 2 planes intersect, their intersection is a line? So that would be 2.7. The good news is it's going to be multiple choice, so you'll get to read and see which one. Okay, so postulate, statement accepted as fact. A theorem, statements that have been proven true. So we're going to prove statements true in proofs. We're going to start proofs Thursday, but they're going to be algebraic proofs, so they will be the easier ones before we get into the real ones. So, kid comes home. My math teacher keeps asking me questions. You'd think she'd know this stuff by now. And then, Dad, it's cold in here. Go stand in the corner. Why? Because it's 90 degrees.
That's a good one.
I thought that was a good one, too. That's a pretty good one. What time is it? Okay, let me unlock your assignment and we'll look at that. Okay.
What was Ravenstein?
Oh, that is
God. How many names do I have? I'm pretty sure.
All right, it should be unlocked.
Anybody?
So refresh your screen.
Take the quiz.
So I do have, hopefully you guys can pull it up, the postulates up there too.
Yeah, it shows.
Okay, good. But like you'll be able to see that there are multiple choice, so you'll be able to look and read also. So like question 1 says there is exactly one line through points J and K. What do you think? Always, yeah. You can't make another line. I mean, there would just be the one line. It'd be the same line if you drew, anyway. So points A, B, and C determine a plane.
Sometimes.
Sometimes, because they have to be non-collinear. So if they happen to be collinear, then they would not be. Good. The intersection of 2 planes is a point.
Never.
Never. What is the intersection of 2 planes? A
Line.
line. Good. If points M, N, and P lie in plane Q, M, N, and P lie in plane Q, then they are collinear.
Sometimes.
Sometimes. Okay, good. You guys are good at this. A line can contain only 1 point.
Never.
Never. How many points does it take to make a line?
2.
2. 2 points. 2 points. Okay. The intersection of 2 lines is a point.
Always.
Always. Okay, good. All right, so now you have to try to figure out which postulate. There's not that many problems, so there's only 16. I don't think it'll take very long today. You're going to finish early.
What
So,
was
like-
2, 3, 4, and 5?
Do what?
What's 2, 3, 4, and 5 again?
I don't know. So this one's talking about lines N and L and their intersection being a point. So what you have to do is go through each of these and see which one is talking about two lines and their intersection being a point. So which one would that be?
2.6.
2.6. So that's how this works. So like number 8 is talking about planes. Do you guys see that? So planes, P and Q, and then their intersection is a line. So now you have to go through and find which one is talking about planes and their intersection being a line. So if you guys need help, let me know, but that's all we're doing today. Tomorrow's read day. Thursday we'll start proofs, and they'll be the algebraic proofs. Have a good day.
So